Today's lesson will be on electricity, and I have a few questions to prompt you with at first, and then we'll go from there to learn about what these all mean. So we're going to look at a couple things here. First, on the smallest building block of matter around us, the atom. And if you recall from way back when, the atom has a nucleus and its electron orbits around it. In the nucleus we have positive charges and then neutrons, and then the electron cloud has all negative charges around there. So what happens is, around this positively charged nucleus, we have negatively charged electrons that are constantly going around and around in the orbit. It's not going too far away from the actual center there because of the polarities pulling back and forth and so on. On each of these layers, it has a maximum capacity of electrons. The first layer can hold 2, then 8, 18, and so on and so forth. Remember that the outermost valence can only hold 8. That is the most the outermost valence can hold. So looking at certain materials like copper. Now copper has 29 protons, which means a balanced copper atom will have 29 electrons also. So if you look at the numbers on here, we have a balanced ring here. Outside here, a balanced ring here. However, the outermost ring only has 1 electron, leaving a space for 7 more. So that means that there's a lot of room for it to grow and shrink down. Looking at sulfur, though, with 16 electrons and 16 protons, we have a balanced ring here and a balanced ring here, and only 2 open electron areas on the outermost ring here. So this one here is a bit different, kind of the opposite end of the spectrum here. So looking at these two materials, a good conductor would be like copper, because it has very few outer electrons, whereas sulfur is a very good insulator. Now what happens here in the entire situation here, we have a bunch of atoms stacked up here, so they're all going to be copper atoms essentially. The outermost electrons here are going to spin around in the orbit around the entire atom here. What will happen is, if they're all lined up, an electron can travel from one atom to the next atom, and then the next one from there. So the electrons are traveling along the atoms themselves. So as the electrons are moving from atom to atom to atom, we have electricity itself. What that means is this whole concept comes from the flow of electrons. So what this all means for us here is that we have electrons flowing, doing something to have lights turn on and other things work, motors turn, etc., etc. The components behind working electricity are voltage, current, and resistance. So we have volts, amps, and ohms. Those are our 3 major components here. I want to understand what's going on between all 3 of those. So to kind of break it down a bit here, this little picture here will help us to understand what those 3 things are. Volts is pressure. Amps is the flow of electrons, how much is flowing through a system. And then ohms is the amount of resistance. So in the image here, we have a garden hose with a thumb capping off the end of it. Now, if you remember when you were a little kid and you had a garden hose in your hand, you put your thumb over the end, like so, the water would spray out a lot faster. So what we have here, the thumb being over the end of the garden hose, is the same thing as saying ohms or resistance. We're blocking off part of the flow. Okay, so as we have resistance going up, the pressure of this water coming out of here is also going up. Now the amount of flow that happens here is decreasing. So less water flowing, more pressure building with more resistance. The same bit of water applies to electron flow as well. So this whole bit here of this correlation between volts, amps, and ohms, that correlation was figured out to be called later as Ohm's law. So Ohm's law, in its simplest form, looks like that, right here. Okay, written out, you'd see it more like these 3 equations. What we have here is we have voltage shown as V in the equation written here. We have current written as I, and resistance written as R. Now volts, the symbol for volts is just V. For amps we have A, and then ohms is an omega symbol. That's how we write it out when we write the entire equation out itself. But the VI and R is how we abbreviate voltage, current, and resistance. Now the abbreviations are kind of weird. Voltage is obviously V for the fact that it's the word voltage and the V is the first letter. Tough stuff there. Current is an I though. Kind of weird there. The I came from the French root word for intensity, which refers to where the whole word came from. So the abbreviation of I was used since then. Now R, again, resistance for R. So these are the equations for Ohm's law. V equals I times R, I equals V over R, and R equals V over I. The simple way to write it out is down below here in the blue. So if I wanted to try and solve for I would simply block off the I and say V over R. Trying to solve for R, V over I. If I wanted to solve for V, I times R. Okay, so I'm going to use that in a little problem down here now. As an example here, I have a little question for you. A flashlight has a 6-volt battery and has a bulb with 150 ohm resistance. With a flashlight on, how much current will the battery be drawn from? So in here, in the battery little box here, we have a 6-volt battery. Okay, the bulb itself is 150 ohms. That's resistance. So we have voltage and resistance. Okay. Now the diagram shown down here, this diagram is saying that the voltage is 6 volts. This symbol here is the battery symbol. Okay. This symbol here is a resistor symbol. Then we want to try and solve for I being our total amperage. So I'm going to go ahead and block off I and say V over R is how I find I. So if I have any two of them, I can solve for the third one essentially. So I'm going to say that if I equals V over R, I'm going to substitute my numbers in. I have 6 volts over 150 ohms gives us my amperage. When I solve for it, I should find that my amperage equals 0.04 amps, which is the same thing as saying 40 milliamps. So my answer is 40 milliamps. So with this Ohm's law, if I have any two of those three components, I can solve for the last missing one, but I have to have two of the three. So that's how I use Ohm's law in a problem. That's how it would look in the real world. And that will conclude today's little lesson here. We're going to continue on looking at circuits, series and parallel, and understanding Kirchhoff's laws.